So we'll do Venus's atmosphere very briefly, and then we'll get into Mars's geology, and we'll then talk about life on Mars and the colonization of Mars. I spent almost the entire class last time talking about the mythology of Venus, so I'm going to skip that on Mars. There's a rich mythology associated with Mars too, but we just don't have the time to do it. And I think Venus is probably more central to more cultures. You know, Mars is kind of hard to see in the sky if you don't know what you're looking for, although it is kind of unique looking. I've been able to see it when we got holes in the clouds the last few days, and it is quite a beautiful sight. You can, if you have just some binoculars or something, you can get a pretty good view of it. But let's back up and pick up where we left off with regard to Venus. So we talked about, and we're going to keep talking about, we can't stop talking about the magnetic activity of these planets because it's so critical. Venus, I did want to mention, has a little bit of a magnetosphere. And this is an induced magnetosphere. It's more like an envelope that occurs with regard to the sun's own magnetic presence, which is generated by the solar wind as it interacts with the accumulated ions at the surface of Venus's atmosphere. So there's this interaction of moving charged particles, charged atoms, really, that are deflecting away that magnetosphere. So it has a bit of a magnetic presence, but it's not sufficient to really shield the planet from serious penetrating radiation and so forth. Now, the atmosphere is extremely thick. That can offer some protection, and that's going to prove important when we talk about colonizing or going there to permanently set up shop and inhabit Venus, because it turns out there's a happy little zone and up at the top where we can potentially hang out if we built some sort of cloud sailing ships where we could benefit from the protection of a layer of this thick atmosphere above us, but be away from some of the more toxic substances. I'll talk about that in just a second. So very briefly, at the surface, the pressure on Venus due to this atmosphere is like 100 times our surface pressure, which makes it not a very fun place for spaceships to be. And we've talked about how the spaceships, the different craft that have landed there have only survived for a matter of minutes, generally speaking. The atmosphere is mostly carbon dioxide, 96.5%. There's a bit of nitrogen, just like our planet. Of course, our planet, most of our atmosphere is nitrogen in the 80% ballpark, which is an inert gas. It doesn't do much. It doesn't react much with anything. So this is kind of interesting. There's these really, really gnarly clouds on Venus, which are very rich in sulfuric acid. And sulfuric acid is really toxic stuff. It has this amazing ability to pull water out of substances, which is fascinating if you think about why Venus is so dry. Again, maybe it did have water in the past, and the water's been sopped up by these chemical reactions. But you want to stay away from that stuff. The sulfuric acid has the potential to take things like carbohydrates and sugars, basically the things that we need for energy for our bodies here on Earth, and rip them apart. It just pulls the water right out of them and produces a really desiccated mixture of carbon and steam and heat. It's an exothermic reaction. So I think that this chemistry probably plays quite heavily into why Venus is such a difficult place to exist. What about life on Venus? You know, there's actually been a fair amount of debate. I planned on doing a bit of a tangent about phosphine. It was a huge debate. They detected this molecule that's traditionally only associated with the metabolic processes of life forms. And people went back and forth about if it could be, it was detected, and whether that detection was faulty, whether if it wasn't faulty, it could have been generated by inorganic processes that we were not aware of. But ultimately, we don't know. So a lot of the debate has come down to, at this point, whether the life that we might find on Venus could have nothing to do with the life that we would find on Earth. In other words, it would use some sort of different molecular structure. It wouldn't use the traditional water-based systems that we consider with life generally on our planet. It could be some sort of, they call it this self-replicating molecular red oil, which is some sort of like polycyclic carbon compound that's dissolved in that sulfuric acid. So something totally unimaginable to us. Try to imagine some kind of life that can exist in a pH 1 solution, something that's just completely acidic, which is really difficult to imagine. Actually, life on Earth is extremely unstable too. So it seems wild that that's possible, but if you think about it, water dissolves almost everything. It's kind of a miracle it doesn't, your whole body doesn't fall apart. And that, of course, has to do with the very careful organization of hydrophilic and hydrophobic regions on your cells and the exclusion, the ability to draw tight barriers around these cells. So maybe. Nothing's been found definitively yet, that's for sure. And people are playing with the idea of how to go and live there. And back as early as the 1970s, the Soviets started making plans for how to build floating bases. And this was seconded by some NASA astronauts as well. There's a gentleman named Jeffrey Landis at NASA, who is a huge champion of the idea that not only is living on Venus, living in the atmosphere of Venus, not only is it plausible, but it's a great idea. I have a little quote from him here. It says, he says, however, viewed in a different way, the problem with Venus is merely that the ground level is too far below the 1 atmosphere level. So that's the 1 atmosphere is what we have for pressure here on Earth. However, at cloud top level, Venus is a paradise planet, which is really something to think about because our breathable air would float very nicely on top of this thick atmosphere. Not only would it float on top of it, it would float at this perfect region where there would still be enough clouds above us to shield that radiation, but we could still dwell in this nice little area. And apparently at that exact happy elevation, the chemistry is much more neutral as well. So I think it's something like about 50 kilometers above the Venetian surface, you will find something that looks a lot like ground level on Earth. And there's other advantages to this too, because the day on Venus is very long. It hardly rotates at all. And this would make, generally speaking, with ground-based, if we were, for whatever reason, to be able to live on the surface or, inhabit the surface of Venus, it would get we would have very different day and night, and they would last for a very long time. However, if we plant ourselves in the atmosphere, we can travel around Venus in some sort of orbit, which would approximate our own day, and therefore be able to regulate our temperature and so forth, and our solar power in a way that wouldn't marry us to the dark side for, days and days and days on end. That's a pretty cool idea, and it's definitely being entertained. So just to clarify that, the solar day on Venus is 118 Earth days. That's how long it takes for one side to see a night and a day. Then there's the idea of terraforming it, right? Turning it into an Earth-like planet, which is definitely quite a long shot pipe dream. Yeah. Yeah, so That's the problem. Yeah, and I think that the solutions come down to the proposals that I've found essentially involve making a series of mirrors. And the idea is you can freeze out that carbon dioxide. So when we go over and talk about Mars later, we're going to see that a lot of the carbon dioxide in Mars's atmosphere, if you can call it that, Mars has a very thin atmosphere. It's frozen down into the ice caps. It's in a form of dry ice. So the strategies for terraforming Venus all come down to regulating the temperature. Venus is what we would call like a runaway greenhouse planet. Mars is kind of the opposite. It's like a runaway refrigerator situation. And so both of those are going to be aimed at controlling the heat. Yeah. Yeah. Yeah, exactly. Exactly. Ooh, like transporting them? I think that like the volume is just unimaginable. It's much smarter to figure out a way to transform the molecules that are there already into something that we want them to be. You know, there's plenty of oxygen bound up in the atmosphere in the form of other molecules, right? There's plenty of raw building blocks. The idea is how can we transform them into something usable? And it all starts with controlling the temperature of the surface, which is just an unbelievably large project. There are like very, very well-developed plans for this when it comes to Mars. You know, people are much less interested in Venus than they are in Mars, which makes a lot of sense. In some sense, you can't even walk around on the surface of Venus. Mars, we could conceivably do that. It comes with its own host of problems as well, but it's much more attractive. Both of them have this magnetic field issue, and I hope that we'll have time to talk about the plans for reinstalling magnetic fields, which seems like some complete science fiction lunacy, but there's some pretty good ideas. And if you did want to develop either one of these planets in the future, it's an absolute must, because even if you were able to develop an atmosphere, it will get cooked out, or it will get blown away, I guess is a better way of putting it. It will get blown away by the solar wind very quickly. The origin stories of Venus are also extremely murky. Again, I think we've touched on this more or less, but what happened, like if it formed in a similar way that the Earth did, what happened to all of this water? Was it simply a matter of this runaway greenhouse effect? In other words, let's say that we can't actually get a handle on our own greenhouse issues here on Earth. Would Earth end up looking something like Venus? I think that's a really interesting, if not plausible, way of looking at the history of it. Whether it's true or not, it's certainly possible that if Earth were to continue to capture heat and fail to radiate it, that it probably would end up looking like something like Venus eventually. Likewise, it's possible that something like Mars could happen as well, where the opposite happens and we lose our atmosphere, right? And it becomes extremely cold and thin. So, you know, and there's very fringe scientists who look at Venus, Mars, and Earth as all different points in the evolution of a rocky planet, you know? Maybe it goes through one stage on the way to the other, and so on and so forth. Both of them seem to be have a much more. They're either much older or they've evolved through these steps faster than the Earth has, and that's a difficult thing to say because we only have records going back 4.5 billion years about any of this stuff. So if Mars turns out to be way older than that, then the story starts to make more sense in some sense, in some way of thinking about it. But again, since science tends to be an extremely conservative narrative that relies upon only the data that we can say we have for sure. We only build stories out of that. It's difficult for us to talk about what we don't know and build that into our models as well. But it certainly looks like they've been through what we've been through. And oftentimes, especially when we talk about Mars, we tend to think of Mars as having once looked like Earth in the past. The evidence for that is tricky because the people really want to believe that. They really want to see that when they look at Mars. And we'll talk about this. Ever since we've been looking at Mars, we try to see things that look like Earth on it. And maybe not try to isn't maybe totally fair, but we can't help but see things that look like Earth. It was a completely foregone conclusion that that Mars had life on it until the early 1900s. It wasn't even up for debate. It's like definitely, because we looked at it, we saw seasonal variations in the albedo and the reflectivity. So there was dark spots that came and went. People saw canals on it. I mean, this wasn't even a debate, right? So we're constantly trying to put these things in the context of what we understand on Earth, and we're very, very hopeful, at least NASA and the people that are working day to day exploring these planets are very, very hopeful that they will find liquid water on Mars. And so, yeah, let's talk about Mars a little bit, or a lot of it, for the rest of the class today. It's the fourth planet from the Sun, obviously, and it's the second smallest, only beat out by Mercury. And Mars does have a lot of really interesting commonalities with the Earth. In particular, the day length is almost exactly the same, which is very peculiar, especially considering it's much smaller than the Earth. It has about somewhere on the order of 11% of the mass of the Earth, which, I actually was quite shocked by that because generally speaking, we think about the Earth. And even if you've seen like science fiction pieces about Mars, you see people walking around on it. But if you see science fiction pieces about the moon, people are like, you're kind of like bouncing around on it. It turns out that it has, the moon maybe has like half the gravity of the Earth. Or no, that's not true. I'm sorry. The moon maybe has like a sixth the gravity of the Earth, whereas Mars has like a third-ish, a little more than a third. But it still doesn't have much gravity. It's a small planet. But it does rotate very similarly to us. And it also, another really peculiar similarity is that its axial inclination, the tilt of it, which is responsible for our seasons here on Earth, is almost exactly the same on Mars as well. So it has seasons, and they're very similar in scale to the seasons that we have on Earth, which is really interesting. These two things are quite interesting. Now, Mars's orbit is much longer. It's further away from the Sun. So it orbits slower. So the year takes not quite twice as long as an Earth year, but somewhere on that order, I think like 1.8. So the seasons are more or less the same in terms of the change in insolation over the year, but they're going to be a little bit more drastic because it's going to spend more time in winter and more time in summer. And Mars, by the way, it is further away. It's about, so if we consider ourselves 1 unit away from the Sun, Mars is about 1.6 units away from the Sun, which means that it's quite a journey to get out there. And that's really something to consider too. People, the longest time that humans have spent outside of this protective magnetic influence of the Earth is on the order of like a week-ish, right? When we went to the moon in the 70s. Once you get outside of this protective region, they call it the Van Allen belt of the Earth, you got to deal with all sorts of nasty radiation problems. You're really just swimming in the solar wind at that point, and it's a nightmare. And this is a problem that has yet to be figured out because to shield that amount of radiation, you need an immense barrier, and they haven't quite figured that out yet. You need something like 1 meter of rock to shield it out, or like 3 meters of water. And so this is a really interesting problem for designing those spacecraft that are going to go between the Earth and the Mars. how are you going to pull that off? And there's some really interesting proposals. I actually have a friend, it's actually one of my wife's friends from college, who's working at one of these subcontracting spacecraft companies building pieces. NASA doesn't build its own spaceships for the most part. It buys pieces from everyone. Like, you need a toilet or something, you're going to hire a company to do that just does space toilets. And she's working on some of these life support systems, and one of the features they're trying to incorporate into it is, not only how do you recycle the water that you bring on board, but can you use the human waste as a shield by basically pumping it into the shell of the, but can you pump it into the shell of the spacecraft and actually use it to shield some of that radiation, which is, I guess, somewhat surprising. I guess human waste is quite a good, your face, yeah, it's gross, but it works, and that's the trick, is you can't bring much with you on these journeys. And so what does that look like? And of course, there's all sorts of problems. There's other health problems associated with it too. Let's get into that in a little, come on, excuse me. There's other problems associated with the transit too. In particular, bone loss, issues with gravity, and these are going to be problems once we get to the surface of Mars too. But let's talk about Mars itself as a planet a bit more. It's less dense than the Earth. So when we're trying to make sense of its history and its past, one of the big things is trying to explain this magnetic field, what happened to it, because the thought is that when we actually look at some of the rocks, we can see magnetism from the past. So we believe that it did have a magnetic field at one point in time, a very long time ago. But what happened to it? And we're not totally sure. Does it still have any liquid core components left that could, potentially be harnessed? Does it have a solid core? We don't know. And so this is a topic of ongoing interest, and we like I said, we do believe that it indicates that there was tectonic activity in the past. There doesn't appear to be any anymore. And there's plenty of extinct volcanoes, enormous volcanoes. So it seems reasonable to believe that there was a fluid component to the underlying interior substructure, but it's no more. And people can study the Mars quakes and so forth. They can do these seismic studies to probe the interior. And there does appear to be some layered component, but in terms of the actual composition, we're not quite sure at this point. The orbits, like I said, is, it's longer. It has a year, which is about 780 days. So, very close to twice ours. It's got a couple of moons too, which is quite interesting. They're barely moons though, they're extremely tiny. And so these moons are called Deimos and Phobos. And they're both very small. So Deimos is only 4 miles wide, really tiny. And Phobos isn't much larger. And they rotate really fast, or actually Phobos goes really fast. Deimos is a bit slower, further out. And they have different fates associated with that. So Deimos is slowly leaving orbit, and Phobos is slowly crashing into Mars. And it's thought that it will be no more very soon. I mean, they're very tiny. So here's the Earth, here's the moon, and then here's the Martian moons. You can hardly see them, they're so tiny. But they're also quite interesting looking little moons. I think it's worth dwelling on them for just a moment. There's been different impactor type missions to these from different countries. They're actually fairly well studied. There's a lot of engineering technical hope that the moons could be used as research stations as we move towards exploring the surface of Mars, which is quite interesting. Phobos over here, it's a very strange planet because it doesn't, very strange body. it doesn't seem to make sense by our traditional models. It doesn't have enough gravity to really hold it together, which is quite interesting. It's so small and not dense that it's thought that it's essentially a big pile of junk that's somehow held together by a little thin crust. Yeah.
Speaking of that, if I'm remembering correctly, aren't there some estimations that Phobos will get torn apart and form like a ring around Mars?
Yeah, as it starts to crash into the place, yeah, it will. It will completely disintegrate. That's the thought. I mean, there's not much holding it together. And this is a huge puzzle. It's getting closer by something like 2 centimeters a year. So maybe in, I don't know, 20, 30 million years, it's going to get so close that the tidal pressures are just going to be too much. It's going to be ripped apart. But that's a long time for us to make use of it. It's very strange. Here's a close-up. This is a false color image, but it is actually photographic images from the Mars Reconnaissance Orbiter. This was in 2008. And the idea was it was created by this amalgamation of impacts with other bodies. But that theory, explaining this thing is very strange because it has, in some sense, very similar composition to Mars itself, but it doesn't totally make sense because it doesn't have enough gravity to stick together, right? So that's a really cool topic of research if anybody wants to explore it more. That's a good final project one. What the heck is Phobos? It's very strange. It doesn't totally make sense. The gravity is so light there that say a 150-pound person is going to weigh 2 ounces on Phobos, right? And so how do you get these rocks to stick together? Why do they have this rather thick patina of regolith that holds them together? These questions are outstanding and quite interesting. And the one thing else I wanted to mention is that in addition to maybe being a place where we could set up different communication stations in our exploration of Mars, there's this idea that we could use it as part of our actual landing process. So the idea is that you go there, you pick up some dust off of Phobos, some sand, and then as you go and land on the atmosphere, you inject it in front of the spacecraft, and it helps the spacecraft to brake and slow down. And this is actually a very cheap way of braking the spacecraft as it lands compared to traditional propulsion systems. The parachute system on Mars is tricky because there's not much of an atmosphere. And, they have this helicopter that they use right now, but it's not like the helicopters that you'd find on Earth. I mean, the blades have to spin at an extraordinary rate in order to get any sort of lift out of it. And it's also very light and so forth. So, yeah, this is a very attractive body in terms of technological progress and colonization of the planet in the future. All right. So, we've been exploring Mars for a very long time. We've been exploring Mars continually since about the 60s, I would guess. The first one was Mariner 4. Viking 1 took some of the first images of it. And then there's been, all the other countries have been there too. China most recently has a lander there in 2021. Russia's been playing with it this whole time. And where we're at with it right now is we obviously have a number of rovers there, and we're trying to actually ask questions about the composition of the surface. And in order to do that, we either have to bring all the instruments with us or we send the samples back to Earth. And sending the samples back to Earth has awakened all sorts of demons because if there is anything living there, do we really want to bring it back here? It's a pretty dangerous subject if you think about it, considering how we've fared as a civilization with, this last pandemic. What would it look like if we had some sort of bug from Mars that ended up back here? So NASA's got all these proposals for, okay, we're going to build a super high-tech BSL-4 laboratory to examine the samples. There's no chance it's going to get out into the Earth atmosphere. And it's like, this is very, very much polarized the scientific community. Some people are like, okay, cool, just be careful. And other people are like, don't do it, no matter what. Do not bring stuff back here from Mars. So, yeah, that's a really interesting point of contention. Right now, we're collecting all these samples with the Perseverance rover, and they're actually being prepared with the idea that a future mission would bring some sort of rocket along that's capable of ejecting these samples, these little test tubes, up into orbit where they can be retrieved by some orbiter and brought back. And this is a very well-developed project, so it looks like it's going to happen, and they're already collecting the samples for this. The question really is whether that's something that we want to do or not. And unfortunately, there's not a great way for our planet as a whole to get together and make rules about these kind of things together. All the different countries kind of do what they want. And yeah, that's a real crisis that needs to be solved as we start to colonize the solar system. If we can't, it's hard to justify, or it's hard to make a plan for how we're going to approach all of these other bodies in the solar system when we can't really even approach other countries right now. We're not really getting along too well. Obviously, we've gotten along a lot worse in the past, so there is progress. I think that's worth keeping in mind. There's never really been less war than there is today, which is great. But there's some serious conflicts of interest out there on planet Earth that are going to have to be sewn up before we can responsibly approach these other planets. Okay, so what about observing Mars? This is kind of a good image of what they'll look like. Have any of you guys seen Mars out there recently? Yeah, a little bit? You guys got to get one of those Starfinder apps for your phones, and maybe we won't have a chance again until after the new year when the skies clear up a bit. But you should start to take note of all of these planets. You'll never see, I doubt you'll see Uranus. You'll definitely be able to see Jupiter. You'll definitely be able to see Saturn, and Mars is pretty visible too. Mars has this distinct red glow to it, and people have been watching it for quite a while. Every once in a while, the orbits of Earth and Mars become such that they align very tightly, and you get an even better picture of it. That happens every couple of years, and you'll probably see something in the news about it, and make sure you get out and check it out. People, just to very briefly touch on the history of it, the ancient Sumerians, again, incorporated Mars into their stories, as did all societies that I am aware of. Very early on, and I think this is where we get the name of Mars even, the Sumerians associated the planet with their god named Nergal, who was the god of war and plague. Yikes. So they told the stories about the terrible diseases that came through their civilization with respect to this body, which was treated as a deity. And they had a whole city who was devoted to the worship of this deity, this Martian deity. That city was called Nineveh. You might know it better as Mosul, which is completely leveled in the most recent conflict. It was alternately occupied by the ISIS folks, and then later by the Allied forces retook it, and it's just been completely decimated, which is quite a tragedy because it's one of the oldest and most historic cities on the planet. And its patron deity was Mars, so that's kind of interesting. The Babylonian astronomers were making regular records. They actually noted the orbital period of it for, they've traced it for like 100 years that we have records of, which is quite fascinating. The Egyptians also were making pretty good records of it by the mid-2nd millennium BC. They understood the retrograde motion of it. This is obviously when the Earth overtakes it in its own orbit, and the planet appears to move backwards, which is quite strange if you don't have a heliocentric view of these things. The Greeks came along and named it Pyros, which is something like fire, which was they also associated with war and death, which I think probably they inherited from the Sumerians. And then it was quite a while before people started to actually try to make up more empirical formulations of what was going on. Aristotle actually was the first person in the record who noted that Mars disappeared behind the moon sometimes and speculated that it must be farther away, which seems kind of obvious, but it was a new idea at the time. The idea of where these things were, as opposed to just being in one plane happening. China, also by the 4th century BCE, was taking measurements of it and understood the orbit and so forth. But then there's, the Middle Ages, the Dark Ages, and nothing was really formalized until Tycho, who we talked about before, started making these very careful observations and was able to actually use the parallax effect, right? This idea that different positions give you different views, and you can kind of triangulate the distance to the planet. And he made a rather decent approximation of the distance of Mars from us. And then, Huygens came along, built this really incredible telescope, which I thought would be cool to show you guys. It basically looks like a telephone pole because it didn't have a tube so much, but he mounted the lens very far away. And he was able to actually make some of the first drawings of the surface of Mars. And this is where the legend began about life on Mars, because he noted these very patchy and transient regions on Mars, these dark spots that came and went with the seasons. And that was it, Mars definitely had stuff living on it at that point. In fact, due to the chromatic aberration of the lenses that they were using at the time, they thought that these had a greenish hue to them. So, of course, they were plants. They came and went with the seasons, just like on Earth, which is a totally reasonable conclusion. It's absolutely wrong, but it was a good idea. Later on, this Italian gentleman came along named Giovanni Schiaparelli in Milan, and he started making these very detailed maps, which included these canals. He called them canali. This really gripped people's imaginations. People were like, oh man, they got cities and streets over there. This is great. We're going to either make friends or enemies for sure. And this was, some people didn't like this idea almost immediately, but the idea of canals persisted all the way up into the 1960s. We literally had to fly over and look at Mars from right above it to realize that, oh no, these aren't actually canals. This isn't what's happening. This is actually an artifact of different surface features that are giving reflective signals that look like canals. And we'll look at the surface features of Mars, but it does have a number of linear fractures and canyons and these little dendritic structures, which are actually quite difficult to explain. But they're part of the reason now that we think that Mars definitely had water in the past, although there's no chemical evidence of that per se. We really are struggling to explain these features still. So we know they're not canals. We know there's no Martians cruising around on Martian highways, but we still are working to explain these surface features. And really the only thing that we can come up with that's more or less agreed upon is that water did it. But there's some other ideas too that I want to explore, some alternative ideas. All right, there it is, Mars next to Earth. It's a little bit smaller, like I said. Interestingly, the composition is rather similar to the Earth. It has this, we think it has this very rich iron and nickel interior composition, which is quite similar to the core of the Earth and much of the mantle. There's a silicate enrichment of that mantle as you move outward. And this is all just determined by density for the most part, and some examination of the extinct magma basalts that have appeared on the surface, trying to deduce what came from within. It appears to have some distinct layer features. Don't, like I said, understand whether there's liquid or core going on there, but when we do the seismic studies, we can see different layers of reflectivity. One thing that's really, really interesting about the surface of Mars is that the northern and southern hemispheres are very, very different looking. This is the surface features. And this, this, to my knowledge, is one of the most starkly contrasted surfaces of any body in our solar system. The moon, sorry, did someone say something? I heard something. Okay. The moon is also quite interesting on the front versus the back of it, but nothing quite as stark as this. And there's different theories about what happened here. I think that the most entertained theory is that the north pole of Mars was obliterated by some massive impact with something approximating the size of a planet that smashed into it at some point and completely resurfaced the north, because the north isn't cratered at all. That's very strange if you think about it. I mean, there's a couple of craters, but it's very fresh up there, and it's not fresh in the same sort of magmatic basalt that you would expect from a volcano. It appears to have just been completely melted over at some point. And they can deduce by the appearance of new craters when this happened, but it doesn't seem like it happened that long ago, which is really fascinating. So something interesting happened on Mars that wiped out half of it very recently. There's thought to be a few different periods in the history of Mars. So some of the oldest features thought to go back as far as we really have in the rock record, which is 3.5 billion years ago. This is called the Noachian period. Following that was the Hesperian period, which is 3.5 to 2.9 billion years ago. This is where we see the production of all those lava plains down around the midsection. Let me go back to that real quick. You see these huge volcanoes over here and these spilled out plains of volcanism. And then finally, the Amazonian period, which was from 3 billion years ago to the present. This is where all of the new meteor impacts were thought to have happened. So the history is a bit murky, and that's to be expected. I think that we'll understand more the more time that we spend there, particularly if we can root out the story of water on Mars, which is the primary fascination of most NASA projects at this point, particularly because it's useful to us if we go there. The soil. Martian soil is not very nice for growing a garden in. It actually contains a fair amount of toxic chemicals, including this salt called perchlorate, which actually will kill you. So it's also a very basic soil, not very basic, but it is basic. And so one of the biggest resources that we'll need to bring to Mars, ironically, if we're going to grow plants there, is compost, manure, right? There's no source for the nutrients that plants would need to survive. And so that's an interesting crisis, how to get pounds and pounds of manure, tons of manure to Mars in order to even set up different biospheres, biodomes. So yeah, let's spend just a moment talking about water, the water presence on Mars. Water as a liquid physically can't exist on the surface of Mars. If we do find it, it would be a very transient phenomena. And why is that? Well, there's this phenomenon we're all very well aware of, which is called boiling a pot of water, right? And what happens when you boil water? Well, you actually are essentially giving the water molecules a bit of kinetic energy. They're moving around, And if you get them moving fast enough, every once in a while, they're going to punch into each other and knock one of themselves off of the surface of the water, and it will go into steam. Generally speaking, the pressure is so strong in the room right now. It's actually a great amount of pressure in this room right now that it keeps those water molecules held down at an ambient temperature. It pushes them down literally from all sides into the container so that they don't boil. But on Mars, there's almost none of that pressure. There's almost no atmospheric pressure. And so any water, like say if you were to just take your space mask off, all of the water in your body would just boil immediately, despite the fact that it's very, very cold on Mars most of the time. The lack of pressure would cause it to leave and go into the gaseous form very quickly. It would just sublimate immediately. And so all of the water that we find is going to be, it turns out to be in the ice form. And all of the water that we hope to find will be subsurface and largely in ice. And the polar ice caps are quite interesting. They actually turn out to contain a large amount of water, and people split hairs over this to this day. Problem is, the polar ice caps are also encrusted in this seasonal layer of dry ice, carbon dioxide ice. And this makes it very tricky to actually drill. I mean, they're like kilometers thick of dry ice over top of these polar caps. So while different spectroscopic analyses have suggested that there's a great deal of water in these caps, there's no way to easily access it. It's going to be quite a drilling mission to figure that out. And I think it's hopeful, but we'll definitely need to get a hold of that water. You know, water is not only essential to life, but it's essential to making rocket fuel. It's essential to everything that we would consider necessary for setting up shop there. And the North and South poles are a bit different. So on the left there, you have the North Pole. And on the right, you have the South Pole. Now, the South Pole is a bit smaller. These aren't quite drawn to scale at all. The North Pole also has this hyper-variable seasonal layer that comes and goes. It grows considerably each year. The South has more of a permanent carbon dioxide cap, which is a bit smaller. But even the South, like there's estimates between 15-30% ice water, and in the North, estimates as high as 50% ice water. I don't have the figure in front of me, or do I? No, not right now. But there's thought that there's potentially enough water there to cover the planet, even in something like several meters of water, which is quite fascinating. There's also landforms on Mars that suggest the presence of liquid water, and this is of flowing water. This is a picture of some ice on the side of a crater. It's false colored in blue, so you can see it better. But the idea is there might be subsurface springs that are leaking water out into it. And this has been a point of great curiosity and investigation. And there's also these dendritic features too. Actually, I want to show you this picture before I get to the dendritic features. So I don't know if you can see this, but there's these little wet spots at the bottom of some of these craters. And for a long time, scientists were absolutely sure that these leakages were liquid water. Again, there's problems with that because liquid water wouldn't really make it very long on the surface, and so they've explained them away in various ways that don't actually involve water. They're perhaps some sort of just mineral that is just a dry granular sand flow type thing instead. It's not really understood. But one thing that's clear, and I regret that I didn't pull a picture of this, but I'll point it out when we have another picture of Mars up on the screen. There's all of these little dendritic structures that really look a lot like river valleys on Mars. And I think this has convinced the majority of the scientific world that there was once water flowing on Mars, because it's very difficult to explain them with any other process. Dendritic processes, what's that mean? It means there's some sort of rifts that occur, and they have this fractality to them where the edges of them seem to bifurcate indefinitely, just like a river, right? As it drains from a mountain, it forms fingers that reach all the way out into lakes or all the way out to the sea. And this is the only thing that we see on Earth that forms these kind of things. There's some really strange fringe theories out there too that have tried to explain these features using electrical processes, which I think are quite entertaining at the least. So this is what happens when you hook up a battery to a piece of wood. And what's interesting is you get very similar dendritic processes from doing this. Now, nobody has any good ideas, as far as I can tell, about what on earth would cause such discharge in a body to cause these features. But it does seem like it's like one of the only other processes in the universe that causes dendritic etchings. And so maybe there were some crazy storms in Mars's history which led to unbelievable lightning events or something. This is really far out there idea, but I think it's kind of cool to ponder. All right. So one thing that's kind of interesting about Mars with regard to all these craterings is that Mars is smaller, so it has less of a probability of crashing into stuff than even, say, the Moon or the Earth. Obviously, the Earth has this nice magnetic shield, which we can basically thank every morning when we wake up for us being alive. But it's closer to the asteroid belt. So that means that it's much more likely to get caught up in things as it goes. But again, for some reason, one side of it is completely blistered compared to the north side of it, which requires a great deal of thought. I would love for somebody to explore that idea a bit more in your presentation, and you can teach us about it. This is a really interesting one. Okay, so we got the surface features back up, and you can see some of these little fingering dendritic regions over here on the left. But one of the things you really notice here is this unbelievable gash down the side of Mars. I mean, this is one of the most prominent features on the whole planet. And it's been the subject of some serious contention about what caused this. And I'll leave you to make your own conclusions. But I'd say the most popular explanation is that this magma, you can see this magma plane that's associated with the large volcanic regions, that this magma plane somehow spread out at one point in time. Much later, as the planet cooled and so forth, there was a rupture which appeared, which is essentially tectonic in nature, and caused this fracturing. So that this fracture wasn't the result of flowing water. It's not a canyon, but it is in some sense a cracking that happens. I don't know. It kind of looks like it got whacked by something to me personally. I don't know. It's a very strange feature. You know, the argument against it getting whacked by something is where's all the debris if it got hit by something, which is a totally salient point. And I don't know the answer to that. But, you know, it just looks like somebody dragged a fingernail across the side, a big, huge finger across the side of Mars. It's a very, very, very interesting feature that's wholly unique in the solar system, which I think our story for its origin will certainly evolve once we begin to explore it. But it does not seem to be carved by water, and that's because it doesn't have an inlet or an outlet. If you look at the Grand Canyon, you can see the water coming down from the mountains and emptying out into the Salton Sea and so forth. And you don't see that with this. It's just a very strange feature. Let's talk just a second about the atmosphere, which is more or less non-existent. You can see just a thin haze there at the surface. It's only about 0.5% of our own atmosphere, like I mentioned. Mostly carbon dioxide, a bit of some trace gases, a little bit of oxygen and water. One thing that's really interesting is there's some methane in the atmosphere, and it fluctuates seasonally. And this has been a huge part of the discussion for why something must be living, which is metabolizing it in some way. There's this really interesting study that they did on one of the first lander missions on Mars, where they took it was called a labeled release experiment, and they took some reactive molecules and they mixed them up in a vial on the surface of Mars with robots. They mixed them up with the Martian soil, and they tried to look at what happened as a result of that. And they also took those same ingredients and they controlled the experiment. They mixed it up with some sterilized dirt. They take the same dirt and they just nuked it, basically. And the results of the chemicals that came out of that were very different between the sterilized vial and the one which wasn't. And there are several NASA scientists who worked on this mission who to this day insist that this experiment proved that there's something alive on Mars. And they're still out there going on about it. So people have had difficulty buying this result. They say that we don't know what it means, but it can't mean that there's life because the other biosignatures just aren't there, which is a perfectly valid criticism. But it was such an astounding result that we still don't really understand how to explain it. And I think that it probably should serve as some caution for when we go there, that we clean our feet before we come home. Because we don't know how we would react to some completely foreign life form that showed up on our planet all of a sudden. Mars is losing its atmosphere. This is not a particularly unique situation, but you can see the different particles, I think it's oxygen and carbon, being blown away from the atmosphere, which probably tells us a bit about what happened to it in the past, right? If we think maybe Mars did have protection in the past with a magnetic field that would shield some of this from occurring, well, it's not happening anymore. I do want to talk a bit about this search for life on Mars. Trying to decide if I want to mess with this today or not. You know what? Let's start with the search for life next time. I don't want to get into it and then have to stop halfway through. But there's quite a saga there, and I think we should talk a little bit about the colonization projects as well. Otherwise, next week we're going to do the big giant planets and start thinking about your final project, because I really hope that you'll learn something new and teach us all about it as well. That's it. See you guys next week. Have a great weekend.